Hello again. So today we are at VUB in Brussels at the Living Lab, and I'm actually meeting Waldo Halle. He is working here as professor, and he will tell me a little bit about where we are actually. So hi Waldo, thanks for having me.
Hi, Isabel, welcome.
So what is that all?
Yeah,
Where are we?
all right. This is the heart of our campus, where we have two living labs, two construction sites, where we really try to stretch the possibilities, the state of affairs in design for change.
Okay, design for change. What is that?
Well, for a long time, we understand now that the many waste that we produce during refurbishments and during demolitions is not because we can't build good buildings, but because the buildings that we build are not adapted and ready for future changes. So we continue to change them with the wasteful consequences and the material consumption that we know. So that has to be done differently.
Okay, so you talk about adaptability. What does that mean in the facade industry?
Yeah.
What makes a facade adaptable?
Well, there are different strategies. We can distinguish two different approaches with a different objective. First one would be design for longevity. The other one would be really design for recovery and reuse of components.
Can you be specific about what that means for the facade, longevity?
Yeah. Well, for each of the strategies, you can apply different design qualities, different execution qualities. And design for longevity would really mean that you have a very generous, generic, but also robust facades. And that means that you have to choose materials and also spatial solutions, architectural solutions that really can stand the test of time, whatever the future function will be of a building, whether it's a house or offices or something else, then you really want high quality materials, for example.
Okay, and how about the second strategy?
Yeah, in terms of recovery and reuse of materials in the future, it becomes really important that they are having qualities like the independence, both functionally, so that technical services are, for example, not integrated in every part of the facade, but also that our components of which the facade is composed are easy to recover, that the connections are reversible, so that we don't damage them, of course, when we want to change a window for a door, for example, or when we want a new cladding, which may be used of second-hand materials already.
Okay, and can you show me something?
Yeah, we have.
Are there examples in the new
Yeah, of
buildings?
course.
Right, cool. Then let's go and see. Okay. Okay. So, what can we see here?
Well, in the Willy van der Meere Living Lab, the designers, makerarchitecten, they chose for an independent outside metal frame that really makes the whole solution very modular. So and also preserves that independence and reversibility.
So this is where the facade will be mounted, actually.
Yeah, yeah. Here you can see that metal framework, which is really the connector between the existing concrete structure and everything that you can imagine that fits in here. So because it's so generic and really makes that you can reach all the connections very easily afterwards, it really allows you, for example, here to fill in an opaque, of course, circular bio-based infill solution with a good energy performance as well.
Okay, so we already see installations that were installed in there. So
Yeah.
it's the complete
Yeah, this also
Also-
only needs finishing.
finishing, yeah.
But in the same framework, you can install a complete aluminum of steel window with which will be easily reachable at the inside to be deconnected. And in theory, you could just demount this one and replace it with the panel next door, or upgrade or make the door smaller or bigger if this would change, for example, from now a demonstrator to student housing again, or to residences for temporary professors, for example.
Okay. All right, cool. All right, so nice to see that. Maybe afterwards we can look a little bit more on details.
Yes.
What about challenges? What are the challenges when you do such a project and when you try to apply design for disassembly?
Yeah, of course, it's not common practice. We have been doing things for the last few decades as easy and as fast as possible. This is really something that requires a bit more thinking, a bit more preparatory work to make sure that, of course, because the different materials come together, different contractors come together here, that they are aligned with each other. For example, you have to make sure that the metal frame is indeed strong enough, but also stiff enough to hold the different infills, for example. That is something you need to think about in advance. So also the design process will be much more integrated.
And what about timing and costs?
Yeah, of course, this because it's not common practice yet, and because certainly in Belgium, but also in other regions, the construction sector is so scattered. People are not used to collaborate. That requires time. But of course, it's up to the client, like the university, to do something about that and hire them, for example, at the same time, so that from the start on, they start working together. And that's also what we did here.
Cool. All right. Thank you, Waldo, for the insights. And let's see in the exercise if we can even dive deeper and see how the connections are done.
Let's have a look at the construction detail of the Circular Retrofit Lab. The question was, of course, how are we going to fit out these old modules built in the 70s, prefabricated in the 70s, concrete modules, back up to current standards? Well, this is how they were looking like when we started the construction site, part of the Buildings as Materials Bank research project, with the ambition to fit it out in a way of different components which could be recombined, reused very easily, really as also an experiment, as an exercise in stretching the limits. How can we build as circular as possible? This is, in the end, the result, where we have the connection between the concrete frames which were already existing and the windows which were placed at the inside, but would have been or are easily exchangeable for other opaque insulated facade elements. The ambition was, of course, to make things as reversible as possible, which means you can disconnect, reassemble things without damaging them, which made it important to have like an intermediary part that connects the windows with the existing frames. How did we do that in the end? So here you have the exterior of the construction detail. This is the interior part. And here it was chosen to build first on a metal strip and a wooden frame as really the placeholder for the window, which allows it to be easily connected, and wood was acceptably insulating here. It's on top of that placeholder, which run around the window frame, that we then could connect the windows and the window metal aluminum frameworks. It's on those components, on those placeholders that we could connect the metal frames. It's a curtain wall profile. Here you can see it. Maybe I'll take another color. The window curtain wall profiles were then the things that are easily accessible from the outside, in which the rest of the window was placed. So here you have always an accessible entry point to take the window apart again, while at the same time this could be completely prefabricated and mounted in place in one piece, but you can take it out without damaging anything of those valuable materials and components.